on chain rule for next year. Here we go. Exercise 20A. You've learnt the first principles. What was the first principles about again? Let's remind ourselves. What are we trying to do? What's the purpose? Yes, Lucy. Finding the gradient, but it's not just finding the gradient, because we know in year 9, finding the gradient, we did y2 minus y1 over x2 minus x1, right? What is the difference in year 11?
Finding the gradient of a tangent.
Good. Finding the gradient of a tangent graph. Just one more piece of information. What are we missing?
There's only 1 point.
There's only 1 point. See, when you find the gradient, you need 2 points. Hence, y2 minus y1, x2 minus x1. That's why you have 2 points, right? Your goal is to find the gradient with only 1 point. And the only way to do that, that's what first principles was if you made the second point very small. That's what the limit of h approach 0 meant. Okay, so just reminding you, first principles was, so FP for first principles, it was the derivative or the gradient is equal to the limit of h approach 0, f of x plus h minus f of x divided by h. Essentially, this just means y2 minus y1, x2 minus x1, but the x's will cancel out naturally, that you would see. And limit of h approach 0 just means if you pick the second point and you made it closer, so the x value, you made it closer to the original, the smaller it is, the more accurate the gradient is of 1 point. Okay, so don't forget the purpose. The purpose is to find the gradient of a tangent line at 1 point. So if you took what Lucy, Will, and Trent said, those are the 3 pieces put together. Okay, it's finding the gradient, but it's the gradient of a tangent line, and it's a gradient of a tangent line at 1 point only, because tangent lines cross only 1 point, not 2. Okay? Then you learnt yesterday a shortcut instead of doing this, because you would have found 17A to do this would have taken ages to do. We learnt the power rule. Okay, so in 17B, you learnt the power rule. Anyone remember what the power rule is, and what type of functions does it only apply to? Akita?
It applies to only power function.
Good. So
It's n times a and n to the power of n minus 1.
very good. Okay. So this rule is a shortcut. Instead of doing f of x plus h minus f of x over h and then limit as h approach 0, if you did that for a power function, you still get the same answer. It just takes longer to do in 17A. 17B, they've figured out a rule and it only works for power functions. What's a power function? Power function is anything with a power on it. Okay, so x to the power of -1, x to the power of -2, x to the power of half, x to the power of 3, or whatever it is. As long as you have x to the power of something, a is just the coefficient. Then the rule was to find the derivative, which means the gradient of the tangent line at 1 point, is n, which is drop down the power, n times the coefficient times x to the power of the whatever the power is -1. Okay? So, here's today's issue. Now we know how to do it for a power rule. When do you use chain rule? Chain rule is when you can't do, you know it's a power function, but you can't apply the rule because the rule says it has to be x. It can't be anything more than x. Okay, so if you have anything more than x, how do you still use power rule if it's not x anymore? If you have multiple terms in there. So what's an example? You see, you know how to do something like this. Once you learn the power rule, you can do something like that. Using this rule, you can say n, which is 3, so it's 3 times 1, x to the power of 3 minus 1. So then it becomes 3x squared. Okay, so the derivative for this is 3x squared. We know how to do this one. dy dx, whoops. Oh, how do I cancel this away? What do I do? Okay, dy dx equals to drop down the power, 3 times the coefficient, times x to the power of 3 minus 1. I'm just using the rule, 3x squared. So that's what you were doing yesterday. Okay? Now, how do I change to the problem that it's still technically a power function, but you can't use it anymore? You can't use this rule. I'll show you. I'll change the problem. It's still something cubed, because remember this was x cubed, which is nice because that was the rule. It was x to the power of n. But what if I changed it to 2x squared minus 1, all cubed? Now, we had to do that from your exercise 17A. The only way to do it was if you separated them to separate terms. Okay, so you have to expand it. But what if I put that to the power of 30? Then you don't want to expand it to like 30 different terms. It will take too long to do. So there has to be a shortcut. That's where the chain rule comes in. Okay, so chain rule will change a difficult problem to make it easier for you to use a power rule. That's why once you start learning all the other rules like a log rule, exponential rule, sine rule, cosine rule, tan rule, you can use chain rule for every one of those. Because chain rule is simplifying a big problem to make it smaller. Okay, so that you can use the rules. That's why chain rule is the bread and butter for next year. Okay, so let's start off. I'm going to teach you how to do this, and then I'm going to give you a quick worksheet to practice a bit more on it as well. Okay, and sort of don't forget what the purpose is, because I'm going to teach you all these rules, and what will happen, well, most likely would happen to a lot of my Year 12 students is they forget what the purpose is. So don't forget it was what Lucy, Will, and Trent said. It is to find the gradient of a tangent line at one point. Okay, that's all it is. If you don't forget that theory, then learning all these rules will make sense. Okay, so here we go. Let's start off. We know how to do this now, using power rule. Now, if we were to find the derivative of this, what is dy dx equal to in this particular case? Can I please have, let's go with Matt, using the rule we learnt yesterday.
6 minus 3 times x 6 minus 1.
Very good. This is yesterday's rule. Okay, drop down the power, so 6 times the coefficient, which is 3, times x to the power 6 minus 1, right? That simplifies down to 18x to the power 5. So that is my gradient. That's my gradient function. Okay, I just don't know where x is. Once I know where x is, I can find the gradient at that point. I just don't know what x is right now. Okay, but once I do, then I can find the gradient. Okay, so this one was easy. Let's up the ante a bit. Let's say, okay, now how do I work now using chain rule? So this one was power rule. How do I change it to a problem that is no longer a power rule, but now we're going to use chain rule to fix the problem? So you see, in comparison, actually I'm just going to write it on a separate side so it doesn't confuse you. So we've got that 18x5. I'm just going to delete that away. If I gave you now y equals to 3, still 3, still to the power 6, but what if I now change that to 2x minus 1? Okay, so you can't use power rule here because the power rule said it had to be x to the power of n. Right now I don't have x to the power of n, I've got 2x minus 1 to the power of n. Okay, so what is the chain rule? This is what I want you to copy down. Okay, this on the top here is your chain rule. So copy this down and I'll explain what it means. Okay, in order to change this problem so that it becomes something easy for you to do, you know this is the issue. The 2x minus 1 is the problem. If I didn't have 2x minus 1 and I had it as x, you guys had no issues. That was fine. You were able to do it here. So the problem is this. That 2x minus 1 is the problem. I'm going to highlight our problem. This is our problem. This is what we don't like. At 2x minus 1. So what they're suggesting in the chain rule is they're saying, well, why don't you call it something else? Let's make it easier for ourselves because we said we can do it if it's just one letter. So why don't you make that one letter? So this is what they normally do. They call it U. They say, let's call this U. Okay, why do you call it U? Because it changes the problem now. Now you would actually have, if you called it U, you would have y equals to 3 multiplied, not to 2x minus 1 to the power 6 anymore. It is now u to the power 6. Very good. You've changed the problem. If you call this entire thing the problem, the issue, if you name that u, that looks easier. 3 times u to the power 6 is something you can do. Because you could do 3x to the power 6, then technically you could do 3u to the power 6. Now, if you found the derivative, this one was dy, which is the delta change in y and the change in x. So that's why we call it delta y, delta x, right? But then in this case here, this is y and u. So when you find the derivative, it should be?
This is 18u to the power 5.
Good. 18u to the power 5, but the notation would be delta y, delta u. Okay? So, in this case here, you would say it would be delta y, delta u, and this is 18u to the power 5. Okay, because you knew that was 18x5, then now it will be 18u5. The notation, instead of delta y, delta x, then it's now delta y, delta u. Okay, because it's changing y, changing u. This is changing y, changing x. So when you find the derivative, this is still a power function. It's just a function in terms of u. So we now call this delta y, delta u. But remember, you made up this u variable. This variable u was made up. It was not a letter. It was just a letter that you made up just to make the problem simpler. So what they've come up to counteract this problem, this thing that you made up, they said, all right, well, if it's dy over dx, what if I did dy over du, so this made up variable, times by du over dx? Because if I do that, when you're multiplying fractions, the du and the du will cancel out because you're dividing each other. And I'm like, yeah, that would work, because then dy du times du dx, if these two cancel out, you get dy dx, which is what you want. You want delta y, delta x. So the only thing you're missing now, you got dy du. You found out what delta y, delta u is. The only thing you're missing is delta u, delta x. Now, anyone, just a quick sort of thinking, anyone know where I'm going to get delta u, delta x from? Because you already did it. I just haven't actually written it down properly. How am I going to find delta u, delta x? See, we know how to find delta y, delta x. Yep. Oh, I see what you're doing. No, there's something more subtle that we've already did. No. Something else. It's something to do with the u, something that I've highlighted. Yeah. So look, you've actually said here, u equals to 2x minus 1. So if you actually write this one out, if I just did this line a bit longer, and if you actually wrote it out, you write u was equal to 2x minus 1. That was the equation you made up. That was the made up equation. So if you found the derivative of the made up, then you should also find the derivative of what you made up over here. And this is in terms of u, in terms of x. So if you were to find the derivative of this, what would you call it? It will be delta u, delta x, which is what you want. See, over here was y and u, you were delta y, delta u. Over here it was y and x, then you said delta y, delta x. Here was delta y, delta u. Then here would have to be delta u, delta x. Okay, so here, if you were to find out delta u, delta x, because that's the change in u with respect to the change in x, you can actually find the derivative of this. This is what you were doing yesterday. Power rule. This is 2x to the power of 1. So let's work it out. What is the derivative of 2x? What's the derivative of 2x again? Seb? Well, were you here yesterday? No, you weren't here yesterday. Ben? Very good. Okay, so the power right now is power of 1. Drop down the power times coefficient x to the power of 1 minus 1. Now, we know that x to the power of 1 minus 1 is the same thing as saying 1 times 2 times x to the power of 0. 1 times 2 times 1. 2. The derivative of 2x is equal to 2. Anyone remember the derivative of minus 1? What's 0? Remember the derivative of any constant. I asked you yesterday, if you were to draw a straight line that was y equals negative 1, it's a horizontal line. So the gradient at any point has to be 0, because you've got types of gradients. You've got positive gradient, negative gradient, 0 gradient, and undefined gradient. So if you were to sketch minus 1, you'll find that minus 1 is a horizontal line. That's why it's 0. But if you didn't know that, you could still find the derivative of 1 by writing it as 1 times 1 is still 1. This is the same thing as writing 1 times x to the power of 0. True? So even though you have the number 1, you still say it's 1 times 1. But then you could also say it's 1 times x to the power of 0, which is still 1. Okay? Why did I do it like this? Because now you can use power rule, and you can say dy dx equals, drop down the power, 0 times 1 times x to the power 0 minus 1. Now 0 times anything is 0. Okay, so even if you didn't know that that graph is a horizontal line, you could still work it out by doing like this. So now, let's put everything together. We said I wanted to find delta y, delta x. That was the problem, right? We found that it's easier if I replaced it with the letter u, and I did. dy du, or delta y, delta u, gave me 18u to the power 5. But, according to the chain rule, if I made up a letter u to make it easier for myself, I also need to find delta u, delta x, which we did. We found delta u, delta x was derivative of 2x, which is 2. Derivative of negative 1 is 0, so that means delta u, delta x has to equal to just 2. Because it was 2 and that was 0, so 2 plus 0 is just 2. Now that you got delta u, delta x, you got delta y, delta u. According to what they said here, if you times those two together, you get dy dx. And so now, delta y, delta x would equal to 18u5 multiplied to 2, and that gives you now 36u5. That's delta y, delta x. Now what's the issue here? With the u. Because we said it's change in y, change in x, but that's not a change in x. That's a u. So what do? Sub it back in. We already said u equals 2x minus 1. So sub it back in, and now you got, this whole entire thing should say delta y, delta x is equal to 36 times 2x minus 1 to the power of 5. Now, let's recuperate and really see what we've done. Okay, you guys have learned power rule. Power rule is a shortcut for first principles. Okay, it was to find the gradient of a tangent line at one point. Okay, we know how to do that. So any power functions. Then I increased the power function's difficulty. I changed it to, what if it's not x? What if it was 2x minus 1? Now what you did was you said, well, the 2x minus 1 is the issue. So you replaced it with a variable. So you called it u. Why did you do that? Because it makes it easier. Now you got 3u6. You can find the derivative, but this is now delta y, delta u. So they're saying, all right, well, if you made up a variable, it didn't have to be u. It could have been a, it could have been t, it could have been z. We're just using a letter, right? So delta y with the made up variable times with the made up variable divided by the delta x that you want, which is here. That's your delta u, that's your delta x. So delta u, delta x finds the derivative of this. And you will then have dy du times du dx tells you the derivative of that problem. So you know how to find the derivative using power rule before. Now we're using chain rule. And what is chain rule? It's just learning to substitute the problem. That's why I'm saying it's the bread and butter, because you can have a normal log graph and then you can change that normal log graph into a complicated log graph. Chain rule just simplifies that. I'll give you a quick example so that you can see the idea here. You see, if I gave you, I'll just fast forward a bit. Let's say I gave you, ignore this. Let's say I gave you this. If I gave you log e of x, you are going to learn the rules on Wednesday, a double session. I'm going to teach all the rules, exponential, log, sine, cos, and tan. You're going to memorize those rules. You're going to be given a sheet, and your job is to memorize the rules. And it'll be like this. They'll say y equals log e of x. If you have a log e of x, then the derivative, they'll say it equals to 1 on x. So then you'll be able to do that. I know, this is just the rule that you're going to memorize. Now, once you know that that's the rule, what happens if I change that problem? How do I make it harder? This is what you'll be doing in year 12. It'll be the same thing, but all they do is put in something like this. And that looks harder, okay? But it's essentially the same skill. Or I can remove the 2 just to make it easier so you can see what I mean. All they've done is you know how to do this, but you don't know how to do this. You see that 3x cubed plus 2 is not part of the rule. So that's when you use chain rule, and that's what you'll be doing next year. Next year, they'll give you a whole bunch of rules, and then you use chain rule to simplify the problem. See, that's something you don't know. that's something that you don't know how to do. So how do you do that? You would simplify the problem by saying, let's remove the problem. Let's call that U, and if you call that U, or any letter that you want, if you call this U, suddenly you can do it. Because now, if that's U, then you have Y equals to log E of U. And that one we can do. Because that's what we said here. The rule says log E of a variable is 1 on X. So in this case here, dy du has to be 1 on U. Okay, so that's delta Y, delta U, then you could do this. So once you can do this, the only thing you're missing is delta U, delta X. And that's essentially what we're doing this entire term. And that's what the others, when they were ahead, they're just doing that theory. They're just learning how to differentiate those problems. And that's why I mean, there's only a couple of rules you're going to memorize, but don't forget the purpose, okay? Because that's where the applications come in. That's where the training comes in, okay? So here we go. This is delta Y, delta U, and that we know is 1 on U. If we wanted to do this problem here, remember you wrote here U equals to 3x cubed plus 2. So we need to find the derivative of that, which is delta U, delta X, because it's U in terms of X. So delta U, delta X, now that is nice. You've learned that. You learned that yesterday. Power rule, that's a power function. So let's use what we learned yesterday. What's the derivative of 3x cubed? What's the derivative of 3x cubed? 9x squared. So now, you can say this is 9x squared. What's the derivative of 2? 0. So if this is delta U, delta X, that's delta Y, delta U. Chain rule. What was the chain rule that you just learnt again? I'm going to write it down in red. Chain rule was dy dx is equal to delta Y, delta U multiplied to delta U, delta X. But now that you got it, you have 1 over U as delta Y, delta U. You got du dx, which is 9x squared. Multiply them together, you get 9x squared over U, which is delta Y, delta X. What's the issue again? Yeah. See, that is in terms of Y, in terms of X, that's a U. That's a made-up variable, so replace it. That's what you said here, U equals to 3x cubed plus 2. So what's your final answer in this case here? It's 9x squared over 3x cubed plus 2. Bam. That's essentially what you're doing. So what did I teach you in this one? I've just randomly taught you that rule. And there's only 5 rules in total. Log, exponential, sine, cos, tan. So if you can memorize that, using chain rule and power rule, you can solve this. And that's essentially all you're doing for year 11. 5 rules, chain rule product. Okay? And that's what I'm trying to teach there. So that's why I said chain rule is your bread and butter. Okay, you can do that for all kinds of functions. You've got to learn how to replace those letters. Okay, now, let's finish off with one example and then I'm going to give you this sheet so you can practice. Okay, here we go. Let's try last example. Here we go. You got 2 times square root of x squared minus 2. You want to find the derivative, which is the gradient. Okay, you want to find the gradient function. Now, that one looks tricky because it's not similar to what you've seen. This one is something easier to do, right? 3x squared minus 5 all squared is easier to do. Your job is to figure out what the power is. Now, square root is the power of half. So another way of writing this is y equals 2 multiplied to x squared minus 2 to the power of half. What is the issue? What's the problem? How do I simplify the problem using chain rule? What would I replace?
X squared minus 2.
Good. X squared minuse 2, you're going to replace that with U. So this is what I'm going to do. I'm going to highlight, this is the issue. I don't like that. That is the problem. So I'm going to replace that with U. I'm going to call that U. So U equals to x squared minus 2. Why did I do that? Changes the problem. What's my problem now? I have y equals to 2. Instead of x squared minus 2 to the power of half, I've now reduced it down to u to the power of half. See, that one's easier. Now you can use your power rule to solve this problem. So let's find out. What's delta y delta u equal to? Seb, have you picked up the pattern now?
Yes.
All right. What's derivative of 2u to the power of half? Yep. Yep, you're right.
U to the power of negative half.
Yes, it is half times, don't forget the 2 there, so half times the 2, so drop down the power, half times the 2, times u to the power, and you're right, it's negative half because 1 minus half, half minus 1 is equal to negative half. So you now have u power negative half. Okay, so I'm just going to clean that mess up there. That was n minus 1. Remember the rule was n minus 1, that was half minus 1. Okay, so now we found delta y, delta u. What do you need? What's the next thing you need? You got delta y, you got delta u.
Delta u, delta x.
Good, delta u, delta x. Now you got u in terms of x. So let's find delta u, delta x. Delta u, delta x is the derivative of this equation. That's got a u, that's got an x. So delta u, delta x has to equal to what? What's the derivative of x squared?
X.
Not just x? What are you missing?
2x.
2x. Good. Bring down the power. So 2 times the coefficient, which is 1, minus the power by 1. Okay, 2 minus 1 is 1. So that's why this is 2x. And then finally, derivative of negative 2. 0. Now you got delta u, delta x, and you got delta y, delta u. To find out using chain rule, we know that dy dx equals to delta y, delta u, multiplied to delta u, delta x. So together you got u to the power of negative half, multiplied to 2x. Because you worked out those 2 points. But u to the power of negative half is the same thing as writing 1 over u to the power of half, using index laws. Remember, if you have a negative power, you can flip it to the denominator. But we know that power of half is like saying square root. So, when you times them together, this is the same thing as writing 2x over root of u. Have I skipped too many steps? We don't need to. But in year 12 you will. Yes. Okay? If it's an easy problem. But in our case, what is u again? U was equal to x squared minus 2. Okay? So, your final answer, delta y delta x, has to equal to 2x over square root of...
That was the best square root.
Yeah, sorry. It's hard to do it nearly on the screen. Now, see what I've done there? This is your answer for the derivative of that. Okay, and that only just gives you the gradient function. We don't know where x is yet. So until they tell you which point on the curve, until they say at x equals 1 or x equals 2 or x equals 3, that's when you know the gradient. Right now you just got a formula to find the gradient. Okay, so don't forget the purpose. Once you learn the techniques, don't forget the purpose. Okay, I'm going to leave this up here because that's essentially what you need to do. Learn to replace the variable, use power rule and chain rule. Okay, I'm going to pass out this sheet. Please practice this. Chain rule is your bread and butter. Chain rule is your bread and butter, so learn it really well. You'll be happy with it next year.
No, I'm getting told.
What did you hear from Lily?
Oh, this is Perry. And I was like, oh yeah.
She probably did.
Alright, good. Chain rule. Practice chain rule. Because Wednesday, I'll be teaching you 5 new rules, and you're going to use chain rule with that in the second session. Okay, so you really got to learn your chain rule first to do Wednesday session, the double session.